I hope that Ernst will have some ideas, thoughts, and experiments showing about blindsight and residual vision. But apart from being the great discoverer of this fantastic phenomenon, which has been studied during the past decades all over the world, he is also the father of another field, an interdisciplinary field called neuro-esthetics. Neuro-esthetics is a kind of a, if you have a Venn diagram, a cross-section of neuroscience and aesthetics, and probably many other things. But since he's the father, he will probably talk a few things, a few ideas about it also. And in general, what I learned from Ernst recently, he will open up windows during his talk, his coming talk, about these things as well as other things, focusing primarily on cognitive patterns within the context of our workshop's major topic. So Ernst.
Good morning. Thank you very much for the introduction. I am not capable to talk about cultural patterns, although I try to study this a little bit on the basis of a philosopher who in our country is quite important, but apparently not everybody knows him, Ernst Cassirer. Maybe it's not known to all of you that modern linguistics was created on a ship between Göteborg and New York when now the word finding difficult start. It comes back. Two gentlemen, and one is Ernst Cassirer. Thank you. Roman Jakobson, thank you very much. They were talking probably a few weeks, and then Roman Jakobson went to MIT, and Maurice Halle, Chomsky, this kind of research was started there, and Ernst Cassirer actually was probably more knowledgeable. He knew everything, and he is also a big cultural philosopher. So that is the part of cultural patterns, which I've talked about now. Then a good life. While I have to be very personal here, then I asked myself, did I have a good life? Yesterday evening, I had a very good life. So I think the question has to refer, what's the time window in which we actually evaluate our life? And I think my life, I'm born 1940, come from the East, I'm a refugee. In the beginning, it was, frankly speaking, horrible. But I was unbelievably lucky, and I think this is somehow, well, harvesting perhaps situations, that I had very good teachers. Like these. That is, I think, as a scientist, we have the opportunity to somehow have freedom to do things. And for me, it was unbelievable. I was really lucky. For instance, that I could work with this gentleman, Konrad Lorenz, the founder of ethology. And it's quite interesting that the cognitive science domain, the research of ethology and human ethology, has somehow disappeared. So this is the biological basis of behavior. He invented or discovered the phenomenon of imprinting. I was lucky to work with this gentleman, Janos Centagutai, together for a year at NRP. Michael Arbe published one blue book together with him. And we had very intense discussions, for instance, about the reference principle when Jerry Edelman came up with the phenomenon, the concept of re-entry. So this was what I really learned from him, enthusiasm. Before 1989, when he had returned to Budapest, I always had to invite him to give talks in Munich, but this was just a cover-up. He came to the West in order to discuss whether one should start a new university in Hungary. So this was the political background. Hans-Lukas Stoiber was the chief of the Department of Psychology and Brain Science later. We just celebrated MIT 50 years, this institute, and that was an unbelievable example of interdisciplinarity. At that institute, the best neuroanatomy you could get, Wallenauter was one of my teachers, or we had philosophy, linguistics, like Jerry Fodor was there, experimental psychology. So out of this department, I think it is really an important influence of modern neuroscience and cognitive science. I got some kind of personal advice from him every Monday morning, together with 2 other colleagues as postdocs. And I learned actually the neuropsychology from Luria, because he was very strongly influenced by Alexander Luria, the Russian neurologist. So in that sense, I somehow am also a grandchild of Luria. This is my doctoral father in Innsbruck, Ivo Kohler. You may not know him, but he did the longest lasting experiment in psychology. It took more than 100 days. He was the person who was wearing goggles to turn the world upside down, so that he somehow, he adapted to that. He went motorcycling, he could skiing with that. And the discovery he made, which is still relevant today and perhaps not really appreciated enough, you adapt to stationary targets, but not to moving targets. So a house, you see, turns upside down, it turns up again, but the smoke comes out of the wrong part. So the dissociation of stationary and movement perception is one of them. Actually, this guy, he imprinted birds, and in faculty meeting, he was playing around with mice, and the dean of the faculty became very nervous, and then he said, "This is more important than what we are talking about here." Jürgen Aschoff is one of the founders of chronobiology, circadian rhythms, and I had the opportunity to work several years in that Max Planck Institute, which became important. And at the end of my talk, if I come ever to my end of my talk, I'll point out the relevance of circadian rhythms of chronobiology for cognitive science. So I jumped already about this figure here. Most of the textbooks have this figure of Corbinian Brodmann, and we still refer nowadays to this figure. He worked also for some time in Munich. And my special field is only this area here, area 17. This is the visual cortex, but I'm making a few remarks about this. So I have only basically one message, and this is set here. The theoretical background. This is distinction between content functions like what we see, what we feel, what we want to do, what we remember. So these are content functions of the brain, and their mode of representation is principally different from logistical functions like, temporal control, I will talk about this, or some other neurophysiological mechanisms or anatomical features of the brain. And the hypothesis I have here, and this is just a message for this workshop, that content functions can be culturally modulated. So there's a genetic evolutionary program providing something like, let's say, linguistic competence, phonetic competence, but the modulation is within a cultural background, within a cultural frame. So value systems, for instance, are imprinted, religious beliefs, and logistical functions are anthropological universals. That is sort of the idea, that this will be shared. And so the paradox of this talk is that we get special insight into anthropological universals if we study single cases. Now, this is somehow a really controversial issue because now everybody talks about big data, right? And I think we can learn a lot from single cases. Of course, we make mistakes, but the point is to harvest serendipity. Whenever you run into something, you may discover something. So some discoveries, quote unquote, are just accidents in my life. So in that sense, I had a good life. I do not talk about the negative aspects. That would not make too much sense. Okay, so here we are. Balázs started the conference with a quotation from Discours de la méthode. Well, Descartes was in fact, as a young student, or young person, soldier in the Bavarian army in 1618, 1619. And at the beginning of the war, during the winter, you do not make war. And he was sitting around, what can I do with my life? And then he conceived this Cours de la Méthode, published 18 years later. But always you see when you come from Munich, Bavaria, you say modern science was actually invented in Bavaria, Germany. And there the disaster started actually also, because you see all my students, by the way, in medicine, have to learn the 4 rules of thinking. This is expressed. So not so much the cogito ergo sum, that is also there, but it comes later in another part. So have a clear mind and no prejudices, no haste. So you should not have any prejudices. You decompose the problem into parts. Number 2, start from the simple to the complex, and do not forget anything. So these are 4 rules. This is the start of rationalism, I think. If you read, by the way, the Discours de la Méthode, Descartes was not a Cartesian. He was this is the reception of others later. Much more important with respect to the start of modern science, I think, is this person. And I think we should be very proud in the West that modern science started with Francis Bacon. By the way, the painter Francis Bacon is probably a descendant of this Francis Bacon. And in 1620, Bacon published Novum Organum, and he started the book with the 4 mistakes we are making. So we are making mistakes because we are humans. So this is the evolutionary heritage. Idula tribus, he calls it. Then we are making mistakes because of individual imprinting. So we are imprinted differently, maybe in China compared to Denmark. We use language. The problem is that we somehow cannot transport thoughts isomorphically to speech. And we make mistakes because we have theories usually implicit. This point here, not mapping thoughts. A patient I studied mainly brain injury patients. He tells me, the problem I have, my thoughts cannot find the words. So he dissociates thinking. He describes with a simple word, these are separate domains. So this remark of a patient is already an answer to a great discussion we're having in cognitive science. So because of this now, because we have the situation here, we are often making mistakes. We have implicit theories. Let me go to residual vision or blind sight, which you're referring to. It is a fact in neurology, or it was a fact in neurology, ophthalmology. If you have a brain injury, let's say in the occipital area, you are absolutely blind. And the problem there is, when I was studying at MIT at that time, the literature on primates. It was observed that primates, rhesus monkey, when you ablate parts of the visual cortex, they still can orient. Now, like a hamster, that is Jerry Schneider's work at MIT. So I thought, why is it that anatomically our system is very similar to that of primates? We are primates, right? However, we are blind and they can do it. And the answer actually to find what is extremely simple. When we do research with humans, we ask them, they have to explicitly say it in words. Well, monkeys don't. So point is, how can we do an experiment where it corresponds the monkey and the human experiment? One way is, of course, to teach monkeys language, or apes. Well, we did not go this way. We did experiments with patients using a very, very simple paradigm, namely just presenting stimuli in the blind region of the visual field. Now here, this is a patient, the first patient where we showed residual vision, or which became later named by Larry Weisskranz and blind sight. So you present targets here in these blind areas, and you simply ask the patient whenever there's an auditory signal which is stationary, look as if you would see it, as if you could identify it. And of course, the patient says at first, why can I look at something if I don't see it? So you have to, well, just try. And so it turns out that actually there's a positive correlation between the position of targets in the blind area and the amplitude of saccadic eye movements. Now this was, we studied it again and again, very proud, I did this with Douglas Frost and Richard Held. And then we sent it to Nature, and it returned, this is nonsense. Everybody knows it does not work. So we did it again, all the experiments, all the control experiments, quite a few actually, and then sent it to Science. This is bullshit. This is nonsense. So, but you never give up. So, and we sent it again to Nature, and it was immediately accepted. Very strange situation, but it was then accepted. And so it became then this phenomenon. And the point here is it's a dissociation between explicit knowledge, where you had a conscious representation of something as something, and some kind of behavioral component. So it became important, I think, in philosophy and in neurology. This patient and all the patients I studied had actually a good life to address this, because it's interesting to observe that most of neurology, well, I think all of the neurological patients, if you would tell them, your phenomenon is what you have is very interesting. I cannot help you, it will not improve. But working with you, we learned so much about, let's say, the brain, that we can somehow deliver this knowledge to others. Other people will have an advantage of that. And this gives sense to these patients, and actually quite a pride also. So in this sense, I think these patients, although they are suffering a lot, and this patient here, A.W., he was a Lithuanian doctor, he really came, he was eager and liked to come to MIT to do this research. So here are the implications of the blindsight and residual as this physician I just mentioned. So it shows a distinction between explicit and implicit knowledge. I think this is a very important thing. So to cite Friedrich Nietzsche, where he said, I cannot say, I think. This is sort of the Cartesian way. I can perhaps say it thinks. So that is sort of the distinction. Now the other thing is that opens, as I've said, the phenomenon is important with respect to rehabilitation of function. That has been done by quite a few people, that although you cannot see, you can orient properly in space. So one of my patients I worked with, he is driving a car more than 1 million kilometers, although he could not see anything on the right side, but he always could orient properly to that area. And then this phenomenon became important in philosophy, the discussion of what is actually consciousness. I think this is, one of these areas. So, a little story, the distinction between explicit and implicit knowledge. We had a chance to, now this is not a patient, an eminent bishop of the Catholic Church in Germany, and he wanted to have his brain scanned. So we asked him, well, let's have 2 experiments. One, we had the resting state activity, measured that, and then he was asked to continuously pray while he was in the scanner, with high concentration. That was one part of the experiment. The other one was we selected statements from the Christian Bible, the Quran, and from Tao Te Ching. Dao ke Dao, Fei Shang Dao, Ming ke Ming, Fei Chang Ming, something like that. So paradoxical statements. He had to explicitly address, say yes or no, I agree to this statement from the Bible or the Quran, and he disagreed with quite a lot of statements from the Quran. He agreed to all statements from the Bible and to all statements also explicitly from the Tao Te Ching. If you scan the brain, what we observed is quite strange. And you have a dissociation between what goes on in the brain and what is explicitly said. When we compare in the brain the activity elicited by Quranic or Christian statements, there was no difference at all. So we looked at 18 different networks, no difference. But a very strong difference to Tao Te Ching, because these paradoxical statements elicit another kind of mental activity. So that's a nice control that apparently his brain really was working. Yeah? The other thing was, and the title of this paper we just submitted, actually it's already accepted in publication, is, does a bishop pray when he prays? Always or never, right? This is sort of the story here. So that is, well, the story about the distinction. Now let's move on to another case. I studied for 30 years now a patient who passed away recently with a blindsight patient. He was traveling around the world and doing somehow participating blindsight using fMRI and MEG and all that. But my colleagues overlooked a phenomenon which I discovered in a lecture. Usually when they're medical students, I bring a patient in and then demonstrate that, in this case, blindness. So this is the visual field. Fixate here, and here's an area of blindness. And so you make a perimetry, and the patient says, no, I don't see it, I can see it, so on an explicit knowledge. And because of the structure here, actually the injury and for the specialist, and the projection from the lateral geniculate to the visual cortex, there's an area of vision here, and an area of vision here. So what you take is you take a stick, yeah, which straddles the blindness, and then the patient reports, okay, I see something up here, and down here. Nothing in between. Yeah? Well, this you do, and by some accident, I was moving the stick. Yeah? And there are a few hundred medical students sitting, and the patient suddenly says, oh, I see the entire stick. Now you are frozen, yeah? Because this is impossible. Of course impossible, right? So you see it stationary, there's two sticks, but then you move it, and suddenly you straddle it, you see it completely. Yeah? Now this started then a lot of experiments. And unfortunately, the patient passed away recently, but he usually said, if you tell me an experiment I have not done, I give you, let's say, 10 euro or something like that. Yeah? So we tried basically everything. For instance, if you present different colors above and below, no completion, although you move it. So you must have identical features, which tells us already that there must be somewhere a connectivity of identical spectral components. Many other things. I don't know show you all this, what we have done. You can measure actually receptive field size. You displace the stick a little bit, so there's completion for up to a degree visual angle and no longer beyond. So if you go to neurophysiology, well, these are data you will read, what is the receptive field size in the perifoveal area? Up to 2 degrees. So apparently, we can indicate here that there's a sensitivity of receptive field size in the visual space. Here in this case, so actually what we are doing psychoanatomy with this kind of paradigm. Or we take an opaque occluder. The stimulus is actually physically not present. And he does not know that. Yeah? So it's not. So you still have completion. That means another pathway in the brain through midbrain is not involved. And going on like this, a very passive. You have it stationary. You do saccadic eye movement. So you create a displacement. So we have completion. In other words, it's not a concept of something which is necessary to create this phenomenon. It's just a physical, mere bottom-up phenomenon. I think this is always a discussion. The patient knows, of course, after some time, there's a continuity. So we have a dissociation between perceptual completion and conceptual completion, which in neurology is an issue. Oh, we know, so we construct this. No, this is a bottom-up phenomenon. Well, it's only in the perifoveal region up to 10 degrees visual angle approximately. Well, then, of course, you say, okay, now let's look in the brain and do a scanning experiment. And so we put him in a brain scanner, actually 2 independent experiments with 2 different scanners, with 2 different teams to see whether we can find something interesting. When you present something in the good visual field, on the left side, you expect activation in the visual cortex in the right side, okay? This is shown here. For a stationary target, a moving target, we have in visual cortex an activation. Now when you do something in the right visual field, you expect activation in the left hemisphere, right? So when we do this, for stationary targets, there is no activation. However, for moving targets, there is an activation, however, on the wrong side of the brain. Not on the left side as you expected, but on the right side. Now, this is completely unexpected. That cannot work because of this figure we created to analyze it on a neurophysiological and neuroanatomical basis. A very, very smart, intelligent reviewer said, this is a heroic attempt, it's of course nonsense, okay? So because it's nonsense by reviewers, we know it must be right. I go not into details here, but you can construct a model on the basis of knowledge from neurophysiology, interhemispheric interaction, actually quite a lot from Giorgio Innocenti, yeah? Inhibitory interaction between the 2 hemispheres, the traveling waves. You can actually transport the activation pattern here by disinhibition, inhibition here to the other side of the brain. So we think that actually there's a new model for restitution of function after brain injury using neuroplasticity and using this network and the play of this inhibition and inhibition. Okay. So let's move on, if this works. It does not. So what I do wrong? This is such an important figure that apparently it does not want to. There must be. Oh, I think I lost something here. I think this is just an energy problem here. Now it's gone forever. We have the question of transport. So I go to what I can work from here now. Yeah. So another phenomenon. I have the tendency to talk too long. I don't worry. So another problem, a retinal paradox. The laser pointer, by the way, now this is for the engineers in Singapore, is one of the most useless technological inventions. Yeah? The classical stick, where the eye is guided, yeah, really is very helpful. Here, what you see is the speaker is very nervous because the eye is not guided. So I should use this, no? Okay. Now, the question here is another very simple one. When we study the sensitivity of the retina under photopic adaptation conditions, maybe these things are too technical for many of you, but you see, this is my fascination of this stuff. Yeah. So you, and if you want, and if you invite somebody like this guy, you have to just go along with this. So when you fixate something, we have the best visual acuity sensitivity, and then it towards the periphery. Well, it doesn't work either. Yeah, no, but you see the pointer, it disappears after 500 milliseconds. So may I can return this now. So what you see here, so you have a decay of sensitivity, then a plateau, and then to the periphery. And when we do this measurements under different adaptation conditions, bright light, dark light, you see that at the central area we have a reduction of sensitivity under scotopic adaptation conditions. But the point here is that we have something like a plateau region. But the most interesting thing is, well, we do not need this. When we measure now apparent brightness in the visual field, independent of suprathreshold, what you observe is very strange. That although at the threshold is very different, now the sensitivity point is turned it around. The highest sensitivity is the low in the center here, and you have 2.5 log units operating range under certain adaptation conditions. Suprathreshold, identical brightness. That means if you move then towards the periphery and come to threshold, the threshold brightness is higher compared to a threshold when you come closer to the fovea. So if you move out, the threshold brightness is increasing because you have constancy of brightness throughout the visual field. Now, if you do this, a psychologist tells you that's impossible. Impossible because it contradicts psychophysical knowledge of Weber and Fechner and Stevens, because they construct the suprathreshold perception, brightness in this case, on the basis of threshold discrimination. So it's simply wrong. So the construction, we have a construction of brightness, equality of brightness throughout the visual field, by the way, not described by Hermann von Helmholtz. He described practically everything. So what does it mean? That means that apparently there's a mechanism in the brain, well, in the eye, in the retina, that somehow makes sure that we create equal brightness. So I've done a lot of research, single cell recordings in the retina, and so you can do summation properties of ganglion cells. And what you observe is that close to the center, the summation starts rather early. We have a spontaneous firing frequency. And if you go to the periphery, you have a nonlinearity. You jump to a higher level in order to create equal contour, equal activity of ganglion cells. On that level, you create equality of brightness. So this is an hypothesis. Well, it was studied. Well, we studied it in cat, not in monkey. But I think it's a good, it is in the retina itself. Why the retina? I really dislike, I'm sorry to say this, Balash, now, I really dislike this cortex chauvinism that is around. That everything is in cortex now, only because of the reasons of technology. So you, last night I learned, of course, the cerebellum is not even looked at. Now, a lot of is going on in the thalamus, in the basal ganglia, and in the retina. Now, in the retina, what you want to have, of course, from the ecological point of view, you want to have equal probability to attend to something in visual field, not dependent on where you look at this moment. So you want to create homogeneity of brightness. And that you better do in the retina, because the colliculus, the next station where you program eye movements towards targets, is already a way station to guarantee proper orientation towards peripheral targets. So we remind ourselves of this gentleman, Theodosius Dobzhansky. Nothing in biology makes sense except in the light of evolution. So this sort of the ethological or ecological principles, I think we should remind. You can rephrase this. For instance, nothing in cognitive science makes sense except in the light of synchronization and time windows. So it's a lot of possibilities we have with it. Well, I threw this in this morning because one patient who came to me, he had tunnel vision. He had a bilateral lesion. His visual field was a tunnel, just a few degrees. And this patient, again, was one example to participate, to gain knowledge. And so what we did, we increased, so many years ago, the visual field size by intense training. So training is possible. And then the patient was sent home, and he came back, and the visual field shrunk again. And then you see, well, now it would have been practical to have a stick, maybe a fence. So and we were not successful to increase the visual field again as before. This was scientifically very important, but it was a disaster made for the patient, because I thought I could improve, but I just frustrated the patient. It was too difficult for him to use vision in order to go around the world. So one has to judge in the restoration of function actually whether the motivation is high enough. So that was a bad thing I did. The other thing, however, we learned that apparently early after an injury, you have a higher chance to improve function and a less chance when you're temporarily farther away already from the injury. So these are some ideas. Now, the question, why I threw this in here, it's not known yet what the mechanism of restoration of function is. And this has to be done. So you identify an area, in this case would be visual cortex, and there's a rest representation. And what we want to do is to increase the synaptic efficacy of the rest representation. So it's my observation or my hypothesis that we have only success in improving long-term function if we have within a session, so the session is always an hour a day, that you decrease intra-session central fatigue. And then next day you jump up in a higher level. So that's the idea. You need, like in sports, by the way, yeah, you have to really stress the system and then you go up. So this, we should, and I think we hope to do this with, with real-time fMRI as an experiment we want to follow. This implies, by the way, something which is neuroanatomically interesting. It's simply wrong that we have a point-to-point projection from the retina to lateral genicular nucleus visual cortex. We have a large divergence of projection. Well, this is anatomically known. The interesting thing is, if you have this, this divergence of projection, if we increase the sensitivity, improve the function, the topological characteristics of stimuli in the field is maintained. So the left-right representation is maintained. This is fantastic, and nobody understands. Certainly, I do not understand how this functions. This is, I think, we have to better really understand this. So this is a part. This was vision. Now comes time. Well, the problem is formulated by many people. Is time, as we experience it, a continuous function, or is it discrete? The best participation, you have a function. Oh, yeah, great. Thank you very much, Lee. You think I should try? Well, you pray like the bishop. Yeah? Thank you very much. Well, you know, I just wanted to find the laser pointer, and then I can do the next thing. Yeah. So, well, of course, Principia Mathematica Philosophia Universalis by Newton is a fundamental. Yeah? Absolute true and mathematical time by itself and from its own nature flows equably without relation to anything external. So this is a fundamental of time in physics. By the way, do not believe any physicist who tells you time is understood in physics. That's not true. Yeah? So I know a theoretical physicist who happens to be my wife, who has written articles about 8 different concepts of time in physics. Yeah? So we usually refer to the Newtonian concept of time. I wanted to say that the most important contribution to phenomenology of time is Augustinus, written in 398 in Confessiones, 11th book, where he has also this famous quotation, "What is time? If nobody asks me, I know it. If I have to explain it, I do not know it. The quid est ergo tempus," and so on. Now, it's quite interesting that in this quotation, Augustinus uses knowledge in 2 ways, as explicit Cartesian knowledge and as implicit acting knowledge. So usually we do not refer to this dissociation of the knowledge systems. So the question here is, Newton, what's the situation? Is time in experience or in processing of the brain continuous or discrete? Well, before answering this question, we have to look at the diversity of research in our field. The foundation of all the relevant questions in time and timing in brains has been done in the 60s. Now, if you talk to a student nowadays, 60s, that far ago, it was in 1960s? No, it was the 1860s. So it started with its talk by Karl Ernst von Baer in St. Petersburg in 1860, where he discovered the concept of a moment. He said different animals might have different moment lengths. That means that the time experience might be different. Actually, the talk was given in 1860, and the publication was in 1865. Ernst Mach was fundamental also in creation of time, concepts in time, and his experiments, for instance, showed that there's no phenomenon of experience of duration if you go below 40 milliseconds. So that is the threshold to experience, well, it's a time point, der Augenblick. This gentleman here, Karl von Vierort, by the way, the first names are either Ernst or Karl. Yeah, this is interesting. Yeah, he discovered the phenomenon of temporal reproduction. You can reproduce intervals, and up to a few seconds you do it veridically. Beyond you cannot. So the gain function of temporal reproduction is very different. That was his book, very important book in 1868. Now this gentleman is probably the most important person in all psychological institutes in the world, because he discovered a way to use reaction time for chronometric analysis of cognitive processes. This is the Donders, so the Donders Institute, of course, in the Netherlands. So here we have it. So these are the persons we have to refer to and give credit. Now, there is something like it's so self-evident in the textbooks that in ophthalmology, neurology, psychology, that temporal processing is continuous. So if you measure something very simple, pursued eye movements, this starts to move and you follow. In the textbooks, what you have are unimodal distributions, like this here, the red line. But one of my doctoral students, who happens to be now a very eminent neuroscientist, Nikos Logothetis, this is from his doctoral thesis, a single case study, if you do it right, you have a multimodal distribution. So to start a movement, saccadic eye movement, hand movement, reaction time, you have to catch a time window. And the succession of time windows is separated by 30, 40 milliseconds in young adults. Elderly people, it might be longer. So it's a discrete temporal processing indicated here on this level. Another thing, well, there are a dozen different paradigms that indicate that we have something processing units of some tens of milliseconds. Temporal order threshold, movement control, discrimination of voiced and unvoiced sounds in speech and all that. There's also nice evidence on a physiological level. For instance, by a Russian physiologist, Nikita Filipovich Podvigin, who discovered neuronal oscillations in the 70s and the 20th century. And he made one mistake. He published in Russian. This you should not do. So although it was actually known, his research, because later it was then the neuronal oscillations of the gamma hertz domain were then discovered again in the late 80s, late 80s of the last century. So Nikita Podvigin did this research, and well, we did some research using auditory evoked potentials. What you see here is this is 100 milliseconds here on the abscissa, and then you have brainstem responses up to 10, 15 milliseconds, and then you have something which you can describe as something like a oscillation. I do it for the moment. Yeah. Why is this interesting? Well, it's a personal story. I got a phone call by surgeons and said, we have a big problem, an anesthesiologist. We cannot control anesthesia in open heart surgery, and also in gynecology when you have cesarean section. Can you help us to somehow monitor brain activity? So what we just had an idea. Why not using auditory evoked potentials? And in case these oscillations represent physiologically something like discrete time sampling. And these oscillations come about by a thalamocortical network. By the way, if you have excitatory inhibitory connections with an odd number of elements, you always have an oscillation. So this is a thalamocortical network, which is implied here. And what happened is, that was really, well, unbelievable. You have an isoelectric flat line, yeah? Oh, God. And this indicates, well, we have thousands of patients now, that the patients in this situation do not process on an explicit level information anymore. So that was somehow a success story, but the success story was so fantastic that an American company wanted to buy all this. We did it together with Siemens. They wanted to buy this product, and said, oh, this is super, but they wanted to buy it because they want not to do it, because it's a better technique and they had something on the market. So we have to deal also with this problem in science, that somehow you discover something and you spend the money of the taxpayer, then a company buys it in order to buy it away. So this is also a frustration, but theoretically it's a nice story. When you ask a patient who has gone through this phase of anesthesia, for instance with propofol or desflurane, generally acting anesthesia, you invariably will observe the patient asks you after the operation, when does the operation start? There's no temporal processing at all. And this, together with all the other evidence, indicates us this machinery of 30, 40 milliseconds is the machinery to create the content for consciousness. Without this machinery on the low level, cortico-thalamic level, we will not have mental content. So that's the machinery behind. Experiments with temporal order threshold show the same thing. Now, this is my contribution to East-West. A colleague of, from Peking University and from Warsaw, Elżbieta Sherlong, they've done a study measuring temporal order threshold in Chinese and in Polish subjects. And what they observe is when you compare, let's say, the temporal order of 600 to 1200 hertz or 300 to 4000 hertz, this is shown here, what you see is that Chinese subjects have a low temporal order threshold for near frequency components and a high, you see this here. They cannot, they are much worse here. Where Polish subjects, they have a very good temporal resolution here for 400 to 3000. So we have double dissociation of functions. The idea being that the language environment, the tonal language, I know what I'm doing here. This is a problem. Yeah. Well, that the language environment creates a framework for temporal processing within limits, so that actually Chinese process information differently, and the conclusion would be also then this is a holistic issue which we will not discuss now. So let me move on. Another time window is approximately 3 seconds, 2 or 3 seconds. And so here we observe that this was a phenomenon of Vierort, discovered 1868. When you have to reproduce an interval of up to a few seconds, what you will invariably do is as shown here. Oh, that was a... When you have to reproduce an interval, what you see is veridical reproduction up to about 3 seconds, and then you have another gain function. So another phenomenon, ambiguous figures. When you have a Necker cube or something, the ambiguous figures turn around after 2 or 3 seconds. When I say 3 seconds, it's not a physical constant. It's an approximately operating range to do something. Or if we have movement control, if we embrace somebody or shake hands, anticipation of movement. The movements are actually embedded, or intentional movements, in a time frame of 2 or 3 seconds. This you can do very simple when you go somebody will shake hands, yeah, and you have the hand longer than 3 seconds. It's uncomfortable. So the emotional reaction indicates there's some kind of natural. It was uncomfortable, right? Yeah. Musical motives versus in poems. So there's an indication. While all this has related also to speech segmentation. When we talk about speech, linguists talk about the lexical, syntactic, phonetic, semantic, prosodic competence. But there's something like temporal competence. In all languages, what we observe is there's a natural segmentation of a few seconds, often bridged by to use the words which are not words to prepare the next phrase. So this is interesting here. Okay. So at first, reproduction. I think it's extremely interesting if you do this very simple experiment on temporal reproduction, that in some schizophrenic patients and autistic children, these are the two classes we have done, they cannot modulate the time. They reproduce approximately always about 3 seconds, sometimes 6, so the multiple. So as you look in these patients into the temporal machinery, the eigenoperations themselves. That is so an indication that, in fact, there's a machinery or a temporal platform of a few seconds, which is somehow apparently was opened up when we look at with this simple experiment. Now let's go to music. Well, we wanted to do the neuro-esthetics thing, right? It is interesting if you measure the duration of musical motifs in the Viennese tradition from Haydn to Mahler, let's say. You very often observe, well, actually it has been studied, that the duration is approximately 3 seconds or so. I'm not going to sing now the motif here of the Flying Dutchman, yeah? But if we do this, you will find out. Now what we did, we put the subject in a scanner, and we changed the duration of the, which was here too fast and too slow. You immediately recognize a motive. There's no problem cognitively. But if you evaluate, if you give it to the right, in the right tempo, this is played by Herbert von Karajan, then you have another kind of activation, in this case, of the auditory cortex. So we believe that actually a time window of a few seconds could well be also a temporal platform as a necessary but not sufficient condition for aesthetic appreciation. So this applies now similarly also to poetry. I started with an American poet, Fred Turner, poems, and this goes on also in China. We compare Chinese poems from the Tang Dynasty to German poems, English poems. If you look at your watch now, and how long is the verse? Shall I compare thee to a summer's day? It's exactly 3 seconds. Thou art more lovely and more temperate, rough winds to shake the darling buds of May, and summer's leaf hath all too short a date. So Shakespeare apparently was a great neuroscientist. By the way, well, we have other languages. Ihr naht euch wieder schwankende Gestalten, die früh sich einst dem trüben Blick gezeigt. This is how Faust starts by Goethe. Or no te conoce el toro ni la higuera, ni caballos ni hormigas de tu casa by Lorca. So verse is always embedded in this window. However, if it's like this, Verlaine, last 4 lines are the best description of a depression. C'est bien la pire peine de ne savoir pourquoi. Sans amour et sans haine, mon cœur a tant de peine. You automatically talk a little slower. That expresses, of course, you use the time window in order to transport the emotion. Well, people say then, okay, this is not true for the hexameter, Alexandrina. This is Nänie, Schiller. Now listen, auch das Schöne muss sterben, das Menschen und Götter bezwingen. So there's a caesura in the line. So the hexameter fulfills also this criterion. I think we can also do experiments to show in the brain that there's a time window of some 3 seconds when we did some mismatch negativity research, which started actually in Helsinki with Mikko Sams and Risto Näytenen And we find that the amplitude, indeed, of the mismatch negativity is much higher, significantly different if you compare these two positions in the anterior regions of the brain. So there's physiological evidence. Of course, we would like to go now to the cellular and molecular level. That is the next step. Now, neuro-esthetics, another remark. This is a Necker cube, a double Necker cube, right? How many possibilities you have to see this double Necker cube? Well, don't try it out all now. 7 different ways. It's extremely difficult, however, by the way, to see it as a flat. But you can train your frontal areas of the brain if you turn it, well, you flip it around. It's interesting that these people like Paul Klee and Picasso and Braque and Feininger, they studied actually visual perception and looked particularly also at ambiguous figures. This picture here by Klee, this is one picture. But because of the construction, it has many different ways. It creates an internal fluctuation. Similar in this picture here, also by Klee. You see, because in cubism, in this art, you create a dynamics because you're using this temporal window of a few seconds. Feininger, there's another Klee picture, or Feininger, where you see this also this dynamics. Okay, finally a remark on circadian and annual rhythms. Can I still talk?
Sure,
yeah.
Sure.
There's another time window. So we look at information processing on a millisecond domain, second domain, and now we go to geophysical cycles because there are two different ways of temporal processing. One is this self-organization for cognitive processing, and the other is adaptation to geophysical cycles. It's the annual cycle, and it's the circadian cycle, 24-hour cycle. Now here we have experiments done by Aschoff, one of the founders of chronobiology and a former doctoral student. They looked at birth rates through the years. In Spain, I think it is in this case. And what you see here from 1900 to 1980, you have a high amplitude of annual cycles in birth rates, conceptions then, of course. By the way, also in suicides. Suicides have also a very clear annual cycle. But this changes in the modern times when we have more artificial light and people are living underground, no longer having, no longer being exposed to the annual rhythm. Now, here comes, of course, an issue between Tromsø and Singapore. In Tromsø, the most northern university in the world, you have a very clear annual rhythm. Here at the equator, much less so. But it's interesting that this, the amplitude reduces, and there are some implications that perhaps the immune system might be affected by this. So I think here we have to better look into this phenomenon. Now let's go to the identity question. This is an issue which was discussed yesterday. Going to circadian 24-hour rhythms. Now, every function we can measure, every function has a diurnal rhythm. Body temperature is simplest. Kidney functions, excretion of hormones, everything. Reaction time, what you have here, body temperature, so cortisol aspects, grip strength, and so on. The problem here is, how is it possible that on the on the subjective level, we have something like the feeling of maintenance of personal identity, although the physiological, biochemical, psychological conditions change throughout the day. And I myself am only identical with myself if I'm well synchronized in exactly 24 hours again. In 4 hours, I will be a very different person. How is it possible, and I think it's a question also in psychiatry, in fact, that some depressed patients sometimes report, oh, I'm a different person in the morning than in the afternoon. So it's the idea that circadian rhythms, the constellation of functions, are important. So the phase map is important. Now take 100 functions. Everybody at a point of time is a place in a 100-dimensional space, with 100 coordinates. So that's a question which I think is unanswered. How to create identity throughout time. And well, it works only because of memory functions, obviously. Well, let's have another. Well, if you go through a bunker, you look at the machinery. Are we actually synchronized every day externally, or do we have an internal body clock? And these experiments have been done all over the world over the last decades. And it turns out if you bring a person in complete isolation, you see that the person has a circadian 24-hour rhythm, approximate 24-hour, like this person here, 25.3 hours, for being isolated for 32 days. I myself was a subject in these experiments, and this is psychologically not uninteresting. You are suddenly completely isolated. There's no contact at all to the external world, nothing. So you have no social signals, you're completely isolated. And I can tell you the first 2 days or so were horrible. You have some kind of, well, mental fire. Yeah? So and somehow the system has to adapt to oneself. Yeah? You have to find yourself in this new situation. And then when the experiment is over, finished, yeah, then suddenly what you experience when you go out, this is an unbelievable feeling of freedom. You have experienced something unique, yeah? Like Ignatius of Loyola describes, I don't know what is in English, you feel free, and you have experienced something. Yeah? So I think to have experienced this is well, in a positive aspect, this is probably why some people in the religious context go to isolation. I put 4 subjects together in a bunker to see whether they are socially synchronized. This is important, of course, for space research. When you travel to Mars, how do you synchronize? So 4 people together, and they have a circadian rhythm of approximately 26 hours. And what you see here, now some detail, but details matter. This one guy gets up always 2 hours earlier. And when we look at vegetative functions, now this is a real discovery, by the way. You look at the kidney function, so here comes now psychonephrology. The person has actually, in this first part of the experiment, and so we just look at the volume of urine here, but you look at sodium, potassium, calcium, you have a beat phenomenon. The person at first has a rhythm, then it disappears. So the superimposition of 2 rhythms at the same time create this beat phenomenon. So the problem is here then that the social desire to be synchronized with others creates an internal desynchronization. But then in the second part of the experiment, the subject said, I don't want to live with them anymore. Yeah? So he's separated. Yeah? So he has his own independent rhythm here, you see. And so when the experiment stopped, one had breakfast, the other had lunch. So this was a complete desynchronization between the individual. So in these experiments, I think it's important to recognize this phenomenon. Okay, I jump over this here because time flies on. No, I should go to this one here. We measure attentional control throughout the day. So where do we attend to right now? And the phenomenon is that using the inhibition of return paradigm, psychologists know what I'm talking about, that we can actually observe that in the periphery of the visual field, we have a very intense orientation, or the attentional machinery is open in the evening for the periphery. But this is indicated here with the red line. So there's a double plot. This is 24 hours here, another 24 hours. So in the evening, a higher attentional control, periphery, and in the morning, the perifoveal area where we have object recognition has a higher dominance. That means that actually we can use circadian rhythms to disentangle cognitive functions. This we do not know before. So if you measure throughout the day, and you have different phase differences, you can indicate, you can derive from that, this is the different machinery behind it. So every area in the brain has a different circadian rhythm, an internal clock, being synchronized by the nucleus suprachiasmaticus of the hypothalamus, driven by light. But you see, here we can then disentangle it. The other thing is, it is a disaster in cognitive science psychology not to control for the time of the day. Because if you do not do it, you discover something very different in the evening compared to the morning. So this has to be taken into account too. I think this is essential. We did some fMRI studies to show this. Now, 2 more pictures perhaps. I'm terribly frustrated by Aristotelian logic. We have a tendency, we all have a disease which I discovered or invented. It's monocausalitis. We try to explain always something in a very most simple way. So like follow Einstein, make it simple, but he said also do not make it too simple, right? So what we observe is, when you look at the cognitive machinery, we have always a complementarity of functions. So obviously this is influenced by Bohr, the Copenhagen interpretation, but in quantum mechanics it's a descriptive complementarity. And what I'm saying here is, in biology, psychology, complementarity as a generative principle. We create content, for instance, that we have a top-down and bottom-up control. Otherwise you could not function. We have the identity of a mental content for some time, for some 3 seconds, but then we have the dynamics. So this is, we have to look at the complementary. We look at content of what it is, what I referred to in the first slide, and the logistics, how it's done, the separation, the complementarity of these 2 phenomena. I will not go through all this. I just go to anthropological universals, what I talked to here, and cultural specifics, which are open by imprinting from cultures. Here, topological invariance and local features. This is actually an East-West question. Professor Chen Lin at Chinese Academy of Science has written an influential paper many years ago about perceptual acts. How do we perceive? And he discovered that actually the first thing we do, we extract from the visual image topological invariance, just inside-outside relationships, continuities, wholes, and then on that basis we construct an image. So this is sort of the holistic Eastern way. Maybe it's true, well, speculation, that only he could have discovered this. We in the West, like take the Hubel-Wiesel paradigm, we look at local features and some construct on that basis the image. Now, I think we have to look at it complementary. Take, for instance, prosopagnosia. So who knows what prosopagnosia is? Good, not too many. So there are some patients after an injury cannot recognize faces, cannot recognize individual faces. That's a big difference. So they look in the mirror and they see a face, but not their face. So the point here is that it's the complementarity of something which is there in the brain, faceness, maybe based on topological properties, and individual characters of your face to bring it together to construct the individual face. So both has to go together. East and West, in this case, have to go together. My last slide, expressing frustration. Other than in chemistry or in biology, in cognitive science psychology, we do not have a taxonomy of function. Like the great discovery, of course, of Mendeleev Meyer was to create a taxonomy in chemistry. So this is, I think, one of the challenges of modern neuroscience, to come to grips with that. We have all models. I have my own taxonomy. Well, the question then is the homology or analogy of functional principles. Do unicellular organisms have analogous or homologous, well, probably analogous functions? Temporal perception, continuous, discrete. Is there homogeneity and inhomogeneity of visual space? Both, actually. The relationship between explicit knowledge, I talked about this. The mapping of subjective phenomena on language, I think, is an open question, as I tried to indicate. By the way, we speak English here. It is this, well, very an unbelievable limitation we have in expression. I cannot say certain things in English I could say perhaps in German. I wrote with Chinese a paper on time, and we wanted to translate Gegenwart, the present. Well, the present in English is something else than the Chinese Gegenwart, which is, somebody told me, something in its identity here now, and Gegenwart in German is really a different meaning. Yeah? So, well, then we still have this hidden phrenology using the bold signals. And then, yeah, Occam's razor misunderstood. You know? So we always search for simple explanation. Entia preta necessitatem non sunt multiplicanda. Occam's razor, the simplest explanation is true. And because of being misled, we think it's one explanation. And I think this is not the way we should think about our research. I thank you very much for your attention.
Number of questions. Can we use 10 minutes from the break and have questions? Because I'm sure that there will be a number of questions there. Please.
There are no questions.
Can I start? Yes. So these 3 seconds, or on the average 3 seconds, which is your, I would say, momentum in the brain. It has been supported by many other ideas. For instance, psychologists who made these random thought sampling experiments realized that when you are, for instance, in an afternoon nap and almost sleepy, and then you're just not thinking of anything, leave your brain open to any mind content coming in and going out. On the average, 3 to 5 seconds, you have a new mind contact. So this is somehow a kind of a unit in the activities of mind. Or our common friend Wolf-Singer showed the synchronization periods can go up to 3 to 5 seconds and then they collapse. So it seems to be something about it.
Yeah, I think I have this. Indeed, I think you cannot find an area where you do not find it. So take, for instance, what you said, sensory motor synchronization. You can synchronize a sequence of signals with a variance of some tens of milliseconds if the next stimulus comes in about 3 seconds. If it's in 5 seconds, you cannot anticipate anymore. So this is in that domain. The duration of intentional movements, the Peterson paradigm, short-term memory, you cannot repeat anything which goes if you are disturbed. So this is, you name it. So for me, this is an evolutionary principle to create a platform of some limited time to create and confirm the identity of mental content, of a perceptual or a cognitive content. And so what we observe in some schizophrenic patients, for instance, this was where you have formal thought disorder, you cannot connect the content. Yeah? So it has some relevance, I think, in neuropathology as well. So for me, it's indeed a fundamental principle. It's like a pre-semantically defined platform. And what some colleagues, engineers, typically physicists, do not understand is a separation of a logistical function which is pre-semantic. It provides a window to present something. Yeah? And so it's, and this complementarity is necessary. There's no example which, well, tell me one where you do not have this phenomenon.
Yeah, just a remark in the question. Remark has to do with your 3 seconds window also here, with the examples you had from poetry. If you want to have examples to your list from prose, which is more difficult, of course, then you should go to medieval rhetoric. They had an idea about how a proper phrase should end. So they made kind of rhythmic, say, reflections on the last 7 to 8 syllables, and made what they called the cursus for the clausus of the, and that was used, and politicians today still use it when they want to end a phrase in the proper way. And there, I guess, 7 to 8 syllables will be within the same kind of frame.
Yeah.
But second, also, you have to add to this time window you have that it has also something to do with the respiratory function, because poetry was said orally. So there's something when you can keep a proper breath, you can recite and go on and go on and go on. And of course, singers and actors are trained to go beyond that, like in the Wagner opera, where it almost is against the human voice and so on. So the respiratory function, I think, in view of communication and so on, would be important here. That was the note. Then
Can I just refer to that, because this is an obvious question, and it's for us very important that we see the temporal segmentation of 3 seconds in other higher mammals, which have a completely different breathing rate. So you see the same phenomenon. So it's just an accident, and in humans it's similar.
Oh, thank you for that information. No, coming to translatability, of course you can translate between languages not word by word, like finding a word for Gegenwart, but by paraphrasing according to the grammatical rules of that language. Some say then you lose precisions, but that's only from the point of view of languages like the Indo-European languages or the Aristotelian logistics. So have you had any possibilities of finding out how the brain works in translation processes? Because there will be a different type of translation when you go into, say, German-Danish or German-English than between German and Chinese, because you have to move to another level of grammatical structure, which probably will function differently, because Chinese is an almost non-morphological language, but works by syntax and context and so on.
Well, my experience in that level is only frustrating. I was trying to translate a book I wrote in German to Chinese with a colleague, and it turned out it was impossible, because it was simply not. Then you rephrase and rephrase. So we have one sentence which is suddenly 2 pages. So my this is a limitation of my experience. What we are doing right now, actually, we have developed a test on leadership, and we want to compare this in different languages. So it's translated into Chinese, back to German, Russian, back to German, and just to see what happens in the translation, back translation. It's basically, well, let's say it's not easy.
No.
The entire research on quality of health-related quality of life, if you take the SF-36, this is a major effort to make comparisons in psychiatry between these subjective statements.
May I put one more question? That's the question you talked about when you can identify the faceness in general, but not individual faces. If I'm not mistaken, it was Roman Jakobsen who studied aphasia after in the 20s and 30s, where it is the other way around. You cannot distinguish between different types of red, but you can see the redness. So there you can, the typology, is that something which goes into that discussion you have there about recognition of faces?
I cannot react now spontaneously to your question. Thank you. I don't know.
Please go ahead. 2 questions, and then we should close. So please go ahead.
So just following on again with the idea about these 3-second windows and musical phrasing. There was a really interesting paper that just came out, I think, a month ago. Again, it's this serendipity of a single instance where they had a chimpanzee who was spontaneously drumming, and they compared it and showed that the phrasing was very similar to human phrasing of. Thank you. So this chimpanzee had phrasing very similar to human phrasing of kind of spontaneous drumming. And one of the things that these researchers pointed out is that in human music making, a lot of that has to do with entrainment, so that the whole group can work together. And this is especially important in like jazz improvisation, but also in a lot of tribal music. That seems to be a function of human music. Has anyone looked at this with humans making music together?
Oh, yes. In such a long talk, you cannot tell everything. Actually, exactly this we do research on that. No, this is quite clear. to synchronize. This is why I rephrase it. Nothing in cognitive science makes sense except in the light of synchronization. This is exactly the thing. Yeah.
Again, about this 3-second concept, don't you think it can be related to learning memory processes?
To what?
To learning and memory processes.
Of course, yeah.
But in which way? I mean, is it easier to remember so we are stuck with this?
Yeah, we are really stuck. Let me give you some kind of tangential answer to that. Why is it actually that in non-writing cultures, you have sort of in epics, in epos, you construct the language or what you want to transport to the next generation exactly that way, like in India, for instance. So I think you use this. And in teacher music, this has been used, the 3-second window has been used by people in order to somehow get involved in that. Empathic relationships, if you talk to somebody, you create some kind of common temporal window in communication, which is quite important in psychiatry. If you have a deal with, let's say, a depressed patient, you cannot look at you. So this is what you create all the time. This is the big challenge, by the way, for, of course, human-machine interface. My colleagues in Japan, in Tokyo, Yokohama, the Tokyo Institute of Technology, they create now robot-human communication, and you have to use in order to create some kind of sense of community that the movement patterns of the robot are similar to ours. So this has a lot of applications. And then, why should children learn poetry? Or music, where you have this. Well, we did some studies exactly on the long-term effect of doing exactly that on cognitive competence, mathematical competence, social competence. You have, of course, a big effect. The Mozart effect, by the way, is nonsense, but you see, this is really, it works. It's important.
And I think there are so many questions to you, but we have to, unfortunately, finish this session because we have to start at 1 o'clock exactly, sharp. But all the questions to Professor Ernst Pöppel can be asked during the lunch break, or send an email to him.